Every year we make about 4 billion flights, but there's been a big cost to the environment. As the world warms, aviation is embarking on a new era.
I'd say the aerospace industry has really changed over the last 12 months in its views on electrification, which is about reducing carbon from transport, reducing noise, and making the business case for transport easier over time.
The term flying car, I think because it relates to cartoons like the Jetsons, they're kind of perceived as imaginary things. We have a product flying. It's there, the technology is available, it works.
So if you look at the electrification, today there are electric vehicles flying around.
What we're going to see is goods and services in the first instance being delivered by unmanned aerial system platforms.
So our role is about developing the right technologies to suit those industries' requirements. So it's understanding how the fundamental science can be deployed in different applications to best effect.
The demand is now to reduce the emissions and reduce the congestion in cities.
It's estimated that the cost of traffic will cost $30 billion. So there is a real need of having small or short distance solutions, transport solutions.
We've seen many of the urban air mobility vehicles, and what we're doing through some of our demonstration activities, looking to incorporate those into short range vehicles initially, and then as the technology improves they'll get into further and further in a longer range vehicles.
We're talking about enlarging the ability of moving people from A to B into a three-dimensional space.
And when it's in the sky, it's performing a journey much more efficiently because you've got point to point.
Aerospace in particular needs really high power density in its platforms, and it's interested in solutions that are very lightweight. We run a large research team, just over 250 people, looking at batteries, electric motors, power electronics, and all of the control systems that bind those together in a whole variety of different applications.
We need facilities like Warwick. We need manufacturing capability that we can rely on the supply chain for.
And because it's a disruptive industry, we need to move quickly as well. So we're working very closely with a lot of our startup type enterprises to make sure we change the culture and move quickly on that.
And especially where we're looking at some of the more innovative parts of the aerospace market, like these small 2-seater and 4-seater aircraft that you see proposed for urban use, that collaboration is going to be absolutely essential to be able to derive the standards and the operating processes that allow the market to be created.
Just moving more and more people into megacities is not going to drive our climate in the right direction, I don't think.
From all the trades and all the trends that we are getting, it says that on 2030, 60% of the population will live in big cities. People will start to see the advantages, and finally we will enter this new revolution.
We should see people being able to hail their ride, to go from the centre of London here to the Midlands to Derby or to Warwick University in less than half an hour.
I mean, it's 100 years since the first transatlantic flight, but if you look forward, it's not obvious that what happened in the past is going to happen in the future. So we are at a crossroads. We've got to take the environmental product seriously.
Electrification improves CO2 provided the source of the electricity is low CO2. And the aviation industry would need an enormous amount of power to fully electrify. So doing that and doing it renewably will be a challenge.